Hello, my name is Naseem, and in last video we talked about the mean and the median of a given data set. So we calculated mean and median of two different data sets, means the runs created by two different batsmen in 10 different matches. And what we find out is that simply calculating mean and median is not enough to understand the behavior of the data points inside the data set. So because mean and median of both of the data set was 53, but after plotting data points into a plotting diagram, what we find out is that the scattering range of data points of two different data sets is not same. All right. So data points means the runs created by batsman 1 was very scattered, means highly scattered, but at the same time the runs created by batsman 2 was not that much scattered, but the mean and median of both of the data sets was exactly same. So what we concluded is that simply calculating mean and median of a given data set is not enough. We must have something else to understand the behavior of this data set, right? So for the same reason, in today's lecture, we will try to understand mean deviation. So this is the third topic which comes in statistics. We will try to understand mean deviation. We will try to calculate mean deviation about a given point inside the inside the range of the data set or outside the range of the data set, and this given point may be mean of the data set or median of the data set. So we will try to understand mean deviation and its fundamental in today's video. So for example, we have a given data set, we call it X. We have number of different data points. Let's call x1, x2, x3, x4, and same like xn, right? We have n number of data points in this data set. All right, so how to calculate mean deviation? So the first step would be we have to decide some point, and then after that we need to calculate deviation of each of the data points about that point. So this point may be anywhere in the range, in the natural number range. So let's call it xr, some random number. All right, so we have to calculate mean deviation of this data set about this point. So the first step would be to calculate deviation of each data points. So what would be the deviation? Let's call it xd1 equals to x1 minus xr. At the same time, xd2 x1 minus xr, xd3 x3 minus xr, right? And at the same time, xdn xn minus xr, right? So these are the deviations of each data point about a given data point within the natural number range of the number line. All right, so once we have these deviations in our hand, we can calculate mean deviation. As the name suggesting, mean deviation. Mean deviation is nothing but the mean of this data set, mean xd1, xd2, and xdn. So in earlier video, we calculated the mean of the data set. Now this mean deviation will be the mean of the deviations of the data set. So how to calculate mean deviation of x equals to xd1 plus xd2 plus xd3 plus, in the same way we need to calculate xdn divided by number of data points, because the deviations will be the exactly same in number as we have the points. All right, so this is how we can calculate mean deviation of a given data set about a specific point. Now there is a problem. Let's calculate mean deviation of a given data set by a fake data, right? So we have x, we have 2 point. Let us calculate. We have 20, we have 60, right? Now we have to calculate mean deviation of this data set about a point which is xr is, for example, let us consider it is 40. All right, so this is x1, this is x2. So what would be xd1 equals to 20 minus 40, because this is the point about which we are calculating mean deviation of this data set, and xd2 would be 60 minus 40. This would be minus 20, this would be 20. when we put this data, these values into this formula, what we find out is that MD of X equals to minus 20 plus 20 divided by 2, because number of data points are 2. All right, what we are getting is equals to 0, means these two values are cancelling each other. So this is a problem. If the selected point about which we are calculating this mean deviation is something which is giving us the equal values of negative and positive inside the data set, then we will get some confusing value of mean deviation. This is not working for us. This is not giving any information about the data to us. So how to get rid of this problem? So we will calculate the absolute values of these data points. So what is absolute value? For example, we have 20 minus 40, and if we calculate absolute value, so this would be always positive 20 if we are calculating absolute value. So this is how we can get rid of this problem. So what will be absolute value of 20 equals to 20 equals to 20. So this way we will get 20 plus 20 divided by 2. So the mean deviation of this data X equals to 20. Now fundamentally what this mean deviation is telling about the data. So for example, let's just draw one quick graph, and draw these 2 points on the graph. Which points? These points, x1 and x2. So let's build a graph over here. In x-axis we have number of the points, we have 1, we have 2. So in this data set we have 2 points, 20 and 60. On y-axis we will have the range of the points. All right, so it will be, for example, 20, it would be 40, it would be 60, it would be 80, right? Now calculate, now just draw first point, which is 20. So we have first point somewhere here. Okay, we have first point somewhere here, and second point we have 60. So we have 60 somewhere here. All right, and let's draw the midpoint, means about which we wanted to calculate this mean deviation, which is 40. So let's draw 40. So 40 will be somewhere here. This is the line of 40. So what this mean deviation of this data about 40 point, what is telling is that all the points, means 20 and 60, is deviating from this point about the range 20. If we have a center line like 140, and we have second point, which is, we have first point which is 20, we have second point which is 60. So this mean deviation 20 is telling us on an average each data point within this data set is deviating from 40 of a value, of a mean value of 20.